Okay, we are interpreting graphs. Diego, please read those first two sentences.
Alberto and Bianca ran a 50-kilometer race. The illustration below shows a graph of the condition of the two runners as a function of.
Okay, good. Thank you. So the graph right there, it shows pretty much their routes, what they did as a function of time. So on the vertical axis, what is being measured? What does it look like? On the vertical axis, look at it. It's on your graphs too. Kilometers, which is measuring distance. And on the horizontal axis, what's being measured? Time, which is in hours. Good. So it says complete the following sentences based on the graph of the function. Can I get a different volunteer, please, to read the first sentence? What does it say? A different volunteer. You don't have to answer anything. Just read the first sentence. Someone else. Can you read me one sentence? Okay, who's going to read it? You going to read it?
Early in the race, Alberto and Bianca runs faster.
Okay, so earlier in the race, who runs faster? We're trying to figure out who's running faster. So is Alberto faster or is Bianca faster? Look at your graphs, please. Is Alberto faster or is Bianca? At the beginning of the race, who is faster? Alberto is faster at the beginning of the race. How do I know it's Alberto and not Bianca? Okay, so you guys are showing me with your hands that his graph is going up. Both of their graphs look like they're going up, though. His
starts earlier than Bianca.
So they start at the same time, but he's increasing faster, right? You said it's more steep. I like that. The slope of his graph is steeper, which means his speed is a little bit faster. So yes, Alberto runs faster to begin with. Can I get another volunteer for the second sentence? Just to read it. Yes, Danielle. Okay, so Alberto maintains a speed of how many kilometers per hour during the first hour? How do I know it's 20? Well, if I look at 1 hour on my time axis, that is 20 kilometers per hour, okay? However, after 1 hour, he gets tired and must take a break. Unfortunately, he falls asleep. What does that look like on the graph?
It's a straight line.
Yeah, it's a steady straight line. What is another word we can use for steady? Constant. Good. They did ask that on the PSAT yesterday. I think it was in a different context, though. If it's asking which of these is the constant, it's a number without a variable. Hey, so you guys did tell me it's where that constant, that horizontal flat line is. He falls asleep. So his distance doesn't change, but time continues going, okay? It says, meanwhile, Bianca's running speed keeps increasing, decreasing, or stays constant. What is it?
Increasing.
It is increasing, yes. Because if you look right here, this is like kind of like a parabola. Yes, her speed is increasing. If it was decreasing, do you know what it would look like? No. If her speed was decreasing, it would not go back down like this, okay? Because on the y-axis, we're measuring distance, okay? So even if her speed gets slower, she's still covering distance, just not as fast. So maybe it would flatten out more. So she'd keep going, but maybe instead of continuing, it would flatten out like that. You see what I mean? It's not growing quite as quickly. That's what would happen if it looked like she was decreasing, okay? And if it was constant, it would be linear. It would be a line, not a parabola or a parabola-like shape. Okay, the first person to cross the finish line is Alberto, Bianca, or nobody? How do you know Bianca finishes first?
She's on the left side.
She is on the left side, but how come it's nobody then? Or why is it not nobody? How do I know that they both finish?
Because they both end on 50.
Because why?
They both end on 50.
Yes, that's what I'm looking for. Because how long is the race? 50 kilometers. So when I go to my 50-kilometer race, I do see that both of them hit 50 kilometers. So they don't tie, but Bianca does win because she's more to the left. She does finish first, okay? She does, exactly. She finishes an hour earlier. Yeah. Okay, is this first one okay? Okay, can we do the second one now? Okay, we're going to look at the second page. Or sorry, second example, second slide. It says a basketball player's hang time is the amount of time the player remains suspended in the air after a jump. So if you look at that diagram right there, pretty much what it's saying is I start, then I jump, I hit a height, and then I come back down to the ground, right? So I don't know how you guys learned this in IM2, but when I used to teach it, when we did parabolas and factoring and maximum and minimum and stuff, I tried to use real life scenarios. So you can also think of this because a lot of you play football. When you throw a football, right, it goes up and then it curves down and it creates a parabola depending on how you throw it. Or maybe if you kick your soccer ball, sometimes you kick it straight up, it goes really high and then it comes down, but it still makes a parabola. Or maybe if you get more distance, it'll make like a flatter parabola. This has to do with jumping, okay? So what kind of shape is this again? This is a parabola, okay? So this is the basketball player jumping. It says the height in meters of superstar Michael Jordan during a jump is shown on the graph below. So this is one of Michael Jordan's jumps, okay? Assume that h is the distance from the ground. So h, vertical is height, is the distance from the ground to the lowest part of his body, which we're going to assume is his feet at t seconds, okay? So we're going to fill in these blanks now. This is the graph of a linear, nonlinear, or constant function. Is this a line? Is that a line? No, so is it linear? No, it's not linear then, okay? Is it constant? No, because you guys told me what constant was. So if it's not linear and it's not constant, it's non-linear. And more specifically, we said it's a parabola. Okay. Next, it says Michael Jordan's hang time is blank seconds. How long is he in the air before he comes back down? He's in there for 1 second exactly?
No, half a second.
He's in the air for half a second? 0.4 seconds.
0.9.
It is in the, but look right. Do you see, Jacob, how I'm measuring 0.5 and then 1? So I'm going to say 0.6, 0.7, 0.8, 0.9 seconds. Good. I can hear you all. So we have decided that it is, in fact, 0.9 seconds. Okay. What about his maximum height? How high does he jump in the air? 1 foot?
1 meter.
1 meter. Yes. So right here is our maximum. So he jumps, which is kind of high. A meter is a little high. That's a whole, like a yardstick, 3 feet. He jumps in the air, like up to here. Hits 1 meter and then comes back down. Yeah, a meter is like almost my height. This is Michael Jordan, apparently. Okay. Finally, it says for t between time is half a second and 1 second, is the height increasing, decreasing, or staying constant? Between half a second and 1 second, what's happening? It's increasing? Oh, it's decreasing right here. Okay. Okay, how is the second one? Is this making sense?
Yeah.
Have I asked you to do any math yet? No, I've literally told you look at the graph and interpret it. Tell me what's going on in this graph, okay? We're going to do the last one. We have 3 minutes to do our last one, okay?
Alrighty.
Finally, I have number 3. Every morning, Tom walks along a straight road from his home to a bus stop, which is a distance of 160 meters. The graph shows his journey on one particular day. With a circle, mark the point on the graph where Tom is furthest distance from home. With a star, mark the point on the graph where Tom returns home. Okay? So, the first thing I need to do is figure out what do I have to figure out? What am I looking for first? What does it say? Read it again. It tells you exactly what to do. Okay, so mark the point where Tom is furthest distance from home. And how am I going to mark this? What am I going to write there?
You're just gonna mark a point.
I'm going to write a circle. So if he starts at home, here is my little home. Because it has a house and a roof. Okay. So I need to put a circle now where he is the furthest from home. Where is that at? Right here?
No, so like the highest.
Right here?
Yeah.
Okay. So this right here, do we agree? Is that his furthest distance from home? It's not. He does keep going, but this is my time axis. I'm looking at my distance axis. Where is the highest point on the vertical axis? No, right here is right. That is the highest point on that graph, on that diagram, on this. Where does the star go now? Why does it go at the end? Okay, so that is not the farthest point. Please listen. I think you're confused. The farthest point from home, distance, is measured vertically. Okay, when he returns home, he is a 0 distance away from his home. He goes right back to the starting point, but time has passed, okay? I will see you all tomorrow. Make sure you do your homework, please.
Are you all tomorrow?
Yeah.